So everyone, so in this video let's continue the things that we have left behind in the previous video. Okay, so in the previous video what we did, we had this array and we had this pointer that was actually pointing to the same address. So actually what's happening in the symbol table says that, hey, there is an array of size 10. Okay, let me just say that this is of size 10. Okay, let's just create a section. It's fine. 0 1 2 3 4 5 6 7 8 0 1 2 3 4 5 6 7 8. Okay, this is my symbol table. So here actually ARR is actually pointing to this. So there will be that like, hey, ARR is basically at, let's say 700. Okay, let's say this is the 700 address. We have something called P also. So P is basically containing the address of ARR. So there's something called P who is containing the address of your array, this one, right? But this P is basically also made, so it also has some address. So P is basically at this address. So if you see, P is basically kept at this address. Now there will be something interesting with this. Okay, we'll see that part. Okay, I hope this part is clear. Till it's clear, right? So now let's see one thing. Hey, if I print the size of my star P, what should be the value? The value should basically be uh, 8 bytes. Why 8 bytes? I've already told you that addresses generally try to actually, like, if in case you're trying to create a variable who is gonna store addresses, they generally are of 8 bytes, right? But this, do you think should be 8 bytes? Obviously no. Why? Because ARR, okay, ARR basically is an array whose size is 10. So 10 and one integer is of integer. So one integer size is basically 4. So if you do this, we should actually get 40. Okay. So here in this case we should get 40. Here we should get in this star piece address we should get 8. So let's see whether we're getting this or not. Okay. So let's even do this to know whether we're getting this part or not. Okay. So firstly, let's see it here. Okay, after creating this, that's not. Okay, let me just comment these things out because we are going to require this right now. Okay, so let me just do this size. Oh, tell me the size of P and also tell me the size of AR. Okay, let's see. So we're expecting it to be 8 and 40. Obviously we know the reason now. 8 should be because it's an address, and 40 because ARR is basically an array. Okay, an array of size 10. Okay, I hope it's fine, clear, right? Okay, second difference. Come here. This is the value of address of P. See out the value of address of AR. Okay, before giving the address, let me just tell you one more thing. See out the value of A. Okay, let's see what are we supposed to get. Okay, let's see what we're supposed to get. Okay, what is this error? Okay, it's error, right? So it's error. Okay, let's see. It's a bit weird, you know. It's a bit weird. What's this? Let's see. What's the thing that is weird? This thing, obviously, I told you that in my symbol table, I have this array who is actually made at 700. So 700 in this case is basically this. Okay, this basically is this consisting saying that this is 700. Okay, P is basically, what is P? P is basically a pointer. Okay, who has the address of ARR, who has the address of ARR. But if you see properly, if I'm printing address of P, it's giving me a different value. Okay, this is different than this. Okay, to make things more clear, let me do one more thing. Let's try to print even P. Okay, let's print even P. Okay, so let's come here and let's copy it, Control C and Control V, and we are printing this and P. Okay, so let's see what should be the answer. Okay, now that's it. Now it will be fine. See properly. Star P is basically, as I told you, it is kept at different address. See, star P means address of P means it is basically made at a different address, right? So you give me this value. So it's this value is basically this 0x6FFE10. Okay, clear is fine. Next is I'm saying, hey, give me the value of P. P means what is the content of P? So what is the content of P? P is basically 700. So 700 basically means this. It is basically the address of your array. So what is the address? It is basically this DE0. See this DE0, okay? Next is basically, hey, print me the address of ARR. ARR, if you see properly, in my symbol table, ARR basically is only one. There is nothing that has been like, see, in this P, a new 8 byte is being allocated for it, right? But ARR is only one. Okay, so and it's actually address 700. So 700 is basically D0. So that's the reason we are actually gonna print ARR as this DE0. See here, DE0. Similarly, ARR is also giving me this DE0 only because they are the same thing only. Either you are giving address of ARR or ARR, they are the same thing since there is no extra space that I have created for, like in case of P. P I have created an extra space that is basically this. That's the reason, see, I'm doing when I'm saying, if you see properly, line number 14 and 15 are same value, but here they are different because this is telling me, hey, where P is kept, so P is kept at 800. This saying me what is the content of P. Okay, P is basically the containing the address of ARR. But here in this case, I'm saying, hey, tell me the address of ARR. So ARR has no extra space like any thing extra. So ARR is just this 700 only. So I'm just printing the 700 which is corresponding to D0 as of now. Also ARR is also same thing. Okay. So this is just the major differences. What are the one difference is basically, see, at AND operator. Okay, both of them are giving me this different operation, different answers. This AND is saying me, this operand is saying me that, hey, this ampersand is saying me, hey, give me the address where P is created. Give me the address of where P is created. But this is saying me, hey, where is the array created? Give me the zeroth index. Give me the address of zeroth index. Even this give me the address of zeroth index. Even this give me the address of zeroth index. Even if I do here ARR of 0, even this will give me the same value as this. Okay, I hope it's making sense. Okay, two major differences are, first is this, second is size. Although this P is pointing to my array, who is an array, okay, who is basically an array, but still this is containing an address only, right? So that's the reason we are getting here 8. And if you see in case of ARR, this is basically an array, that's the reason I'm getting here 40. Okay, this was just some small differences, I should say, like just for clearing your basics clear, making your basics strong. Okay, I hope it's making sense what we are actually doing internally. Okay, one more thing I would like to do. Okay, so I hope till here is fine, right? So let's understand one more thing. Hey, this P is basically containing the address of ARR. Okay, so okay, it's containing the address of ARR. So let's understand this part. So let me erase this part. Okay. And we have something called as ARR, who has address, let's say 700. So P is also having 700 within it. I wrote here. So even ARR is pointing here. P is also having the address of the same thing. So did you see? I can write this ARR plus 0, or basically this. What does this mean? This means that, hey, tell me, dereference this value, because ARR is basically pointing to 700, and tell me what is the value kept at 700. So we were keeping value 10 and we're getting 10 is our answer. Here if I do here star P, then obviously I'll also get 10 only, right? Let's see this. This is two small things. Obviously we've seen it, but let me just see it again. See out. Let's not print this part again, because this part obviously is clear, right? So let's just keep it like this. And now let's me print just what are printing, star here, and see out. Interesting thing, I'll just okay, P, okay, they're gonna give the same value obviously because they are the address of same thing, and just dereferencing and getting the same value. So we'll get 10 10. So let's see what we're getting. We're getting 10 10. Okay, that's great. If you see properly, I told you that this is an array. This is basically an array, right? We can actually do this. ARR of 0. It will give me this thing, the same content. Similarly, this is basically pointing to an array. You can even do this. P of 0. What does this mean? You can actually treat your pointer that you have created, okay, as an array, as if like this was an array. Making sense? This will help us when we'll do the function part. Okay, when we'll see how arrays and function interconnected, we'll see that. See here, what we are receiving, we only have the address of ARR. Okay, we only have the address, but I can actually treat it as if this was a Killian array. Okay, even if you do this, let's just see out ARR of 1 and int here, and if I do see out p of 1, they will give me the same value. Okay, so see here, either you do this star p and get the value, or you can even do p of 0. Okay, since that your array is since ARR is actually an array. Okay, so if you see properly, let's see what we'll get here. For this 3 we'll be getting what we'll be getting, we'll get 10, and ARR of 1 is 9, so we'll be getting 9. Okay, so 10 10 10 9 9. We are expecting our answer is this. Let's see what we're getting. 10 10 10. Okay, we have one more 10. I think I've printed 10 4 times. Let's see where we have printed one more time. Okay, we're printing 10 times. Okay, we'll just see where we have printed. ARR of 1 0 PTR, and then where I'm printing, I'm having 1 2. Okay, yeah, here AR of 0 even here, right? Because even this means that it's 10. So 10 10 10 10. This means, what is this? This means print the content of AR of 1, and even this is saying you can use your pointer that you're pointing to an array as your, as if it was a point an array. Okay, so p of 1 is gonna be giving me 9. Okay, so 10 10 10 10 9 9. Okay, I hope this is clear. Okay, clear, right? The basics are somehow clear, right? Somehow it's getting clear, right? Okay, now let's move to something called a bit weird. Okay, something things will be a bit weird there. They are known as character pointers. Okay, so for that